Let's begin planning the sequencing of our operation. First, let's pull up the structural drawings and look for how many panels we will be placing. Access for the crane will be coming in on the west side of the building, and for this operation, the crew has decided to begin from the southwest corner of the structure and building counterclockwise. With this information, we can now properly lay out our casting beds in a location that provides the needed access for equipment. Here we can see that we need a total of 3 casting beds. Since the crane will be accessing on the west side of the barn, our casting beds will be on the north, south, and east sides of the building. We have to make sure we add the dimensions of the panels correctly and leave enough room for formwork and supports. Double check the crane specs to be sure you have enough room for the operation before we place the casting bed. To begin our formwork, we find our information for the formwork and dimensions on the structural plans or TP plans. This is why having a sequence plan and enough room for equipment between the casting bed and footers is so important. Panel formwork must always be laid out with the crane operation in mind. Access is everything. The plan for this operation is to start lifting with panel E1 and working counterclockwise, lift each panel one after the other, completing the operation with panel A1, making a loop around the structure's footing. Remember, these panels approximately weigh 30,000 pounds. The less time in the air gives us less chance for an incident. Forms used to cast tilt-up panels primarily are edge forms, like those used for slab-on-grade work. When wall thicknesses are greater than 10 inches, plywood form panels can be used instead. Forms may be supported in a number of different ways, including the use of wood cleats or plastic supports. Windows and doors are created in tilt-up panels by blocking out the openings in the form. Cleats are placed inside the opening. Sometimes spreaders should be used to prevent larger frames from bowing in. When door or window frames are used as blockouts, make sure the edges of the frames are protected. After edge forms are completed, we'll begin to add aesthetic features to panels using form liners and reveals. These will be found in our architectural plans. Notice how all the plans call out both type of liner and depth. Now let's go to the tilt-up details page to get a better visual looking at the cross-section views. Now we know each edge gets chamfer in what size, along with the gap size between the panels, sealant installation, and depth of reveals. Using these cross-sections are necessary for you to get a better mental image of what you are forming. Release agent is a liquid substance sprayed on edge forms, casting bed, reveal strips, and form liners to allow forms and panels to be removed easily. Always spray 2 applications. Never spray on rebar or embedments. Rebar, or welded wire fabric, is placed in the forms after openings, decorative features, reveal strips, insulation, and form liners are in place and before the concrete is placed. Although reinforcement is needed for the fabrication and strength of the panels, the amount of the reinforcement is more to limit the cracking of the panels when they undergo the immense amount of stress and bending when they are lifted. The engineer may require additional reinforcement to compensate for the lifting stresses. If there are openings, the lift may require a strong back. In this video, you can see the bend in this panel during an edge lift. For this reason, we only lift small panels by edges with engineer's approval. Right now, the only thing preventing the panel from breaking is the tensile strength provided by the rebar, but eventually the weight of the panel is too great and it breaks. Follow the plans closely and use the right lifting process for your panel. There are several types of embeds in the tilt wall panel. Although we usually consider the weld plates as embeds, remember anything placed inside the concrete is considered to be embedded inside the concrete. Some structural embeds or embedments used for the erection process include beam pocket liners, weld plates, attachment plates, support angles, brace inserts, and lifting inserts. Some of the architectural features that are embedded in the wall will include ridge form liners for insulation, veneers, decor form liners, and other aesthetics. Inserts and embedments must be properly positioned inside the forms and form edges as per plans and specifications. Placement of embeds can be found in the structural drawings, coordination drawings, and erection manual. It is always best practice to look at all the drawings and verify the dimensions of the embedments before placement of the embeds. Let's look at panel D2. Here on our coordination drawing, you can see that our team has already vetted through the plans to help our field team lay out the embeds and inserts quickly and accurately. Elements of the panel are even color-coded with dimensions measured from inside the formwork to the center of the embeds. They also found upcoming items that could be problematic. These will be questioned in an RFI and sent out to engineers to see what inserts can be moved to protect the reveal. There are many types of inserts. Let's look at the most common ones. Your drawings and specifications will have the appropriate inserts already picked out for you. To lift and place panels, we need the lifting and a bracing insert. The brace insert has wire legs welded to a coil with disposable plastic plug with antennae to locate the insert after concrete placement. The wire legs have plastic feet to prevent corrosion at the concrete face, and the number and location of brace inserts will vary on the dimensions of each tilt-up panel. The lifting insert is designed for tilt lifting panels. The insert develops a high pull-out strength for the lift and also has integrated plastic former with antennae to identify its location after placement. Once the disposable former is removed, the lifting insert is exposed and the clutch can be installed. The clutch connects the tilt-up insert into the crane rigging and lifts the concrete panel from the casting surface. The ring-shaped hook securely into the loop of the insert for lifting and handling. The design of the lifter discharges the lateral forces of angular lifting directly into the tilt-up panel. Once lifted and braced in position, the lifter can be safely removed from the ground. All erection calculations are performed under their direct supervision and reviewed by the professional engineer and is communicated in the panel book with all the information you need to perform this operation. Some panels have a lot of openings that cannot support its own weight during the lifting process. Strong backs are used to reinforce these critical areas of the panels during erection. As a guideline, when you have any dimension that is less than 2 feet, or a panel thickness less than 7 inches, a strong back is recommended. Notice that the inserts for the strong backs are the same as the bracing inserts. Look on your plans and make sure they're in the right location. In some cases, lifting inserts cannot be found or may become unstable. We will then need to notify the engineer for a location to install an emergency lifting plate. This is not preferred lift and is not considered to be a best practice. This lift is now critical because the chance for an incident has grown considerably. Always quality check for inserts and other embedments before placing concrete. Before we lift the panels, let's take a minute to talk about safety. Due to the immense weight of these panels, there must be a quality check on all components before lifting. Can you imagine a damage one would receive if struck by one of these panels? Always quality check your inserts and clutches for any instability to make sure all clutches are fully engaged in the buckets. Let's look at what happens when a crew lets their guard down and there's a rigging failure at the clutch location.